This video is about some more properties of functions. First of all, practice for odd and even functions. Determine algebraically whether each function is odd, even, or neither. As we know, when f of negative x equals fx, we call this is an even function, and the graph will be symmetric about y-axis. When f of negative x equals negative fx, we call this is an odd function, and the graph is reflected across origin. Therefore, first of all, we need to figure out negative fx. That's the opposite of fx. For number 4, we got opposite of 4x fourth power is negative 4x to the fourth power, then plus absolute value of x. For each term, we got its opposite. Then we need to work on f of negative x. Means every single x for original function, we need to change into negative x. So we got the 4 negative x to the fourth power minus negative x in this absolute value. We know that for negative sign to the evens power, that equals positive. And a negative sign we do odd power is still negative. Therefore, for negative sign to the fourth power, that's positive x to the fourth power. Then we bring down this 4 minus for absolute value of negative x equals the absolute value of positive x. So we got absolute value of x. Compared to the opposite and original function, we know this one equals f of x. So it is even. The graph will be reflected across the y-axis. Now let's go to number 5. Negative f of x, we got positive x to the fifth power, positive 4x to the fourth power, minus 10. And f of negative x means every single x turning into negative x. So we got negative x to the fifth power minus 4 negative x to the fourth power plus 10. Remember, for f of negative x, you need to plug into the original function. Then we simplify. Negative sign to the fifth power still negative, so x to the fifth power. Negative sign to the fourth power, that's a positive x to the fourth power. Remember, you have to do exponents first. Then you will get negative, that's positive x to the fifth power, minus 4x to the fourth power plus 10. Then you compare to the opposite function and the original function. You could say this one not equal to negative f of x and not equal to f of x. So it's neither. Now let's go to number 6. Negative f of x. For fraction, you have a over b opposite. That is a negative a over b. So we need to change the opposite of a numerator. That is 5x to the fourth power. Denominators stay the same. Then for f of negative x, every single x for the original function, you need to change into negative x. So you got the negative 5 negative x to the fourth power, 6 negative x to square plus 1. Then do the exponents first. Negative sign to the fourth power, that's positive x to the fourth power. Negative sign square, that is positive, so we got the x squared. Now we simplify, we got the negative 5x fourth power, 6x squared plus 1. Compared to the original and opposite function, we could see equals the original. So it's a even function. And it will be reflect across the y-axis. For number 7, negative f of x equals positive 3x third power minus 6x to the fifth power. F of negative x means every single x turning into negative x for this original function. Therefore, we got negative 3 times negative x to the third power plus 6 negative x to the fifth power. We do exponents first. So negative to the third power still negative. X third power, that's x third power. For negative sign to the fifth power still negative, then x to the fifth power. Then we do multiplication. Negative, negative, that's positive. So we got 3x third power. Positive, negative, still negative, 6x to the fifth power. Then compare to original and opposite, we could say equals opposite of fx. Therefore, it is an odd function. And the graph will be reflected across the origin. Now, practice for finding domain. For finding domain, you have to remember the following rules. For rational function, denominator not equal to 0. For square root of function, radicand must be greater than or equal to 0. For rational square root of function, radicand greater than 0. For logarithm function, argument greater than 0. For number 8, we know this is a rational function, so we have to make sure your denominator not equal to 0. This is the denominator. So we set up the domain. That is 2x third power minus 32x not equal to 0. Common factor, that's 2x. We got the x squared minus 16 not equal to 0. Still factor, because we can do those factoring, x plus 4, x minus 4 not equal to 0. That means your x1 not equal to 0, x2 not equal to negative 4, x3 not equal to 4. So we can write down the domain x not equal to 0, 4, and negative 4. Now let's go to number 9. For number 9, we know this is a square root of function. For square root of function, make sure radicand greater than or equal to 0. We got the radicand in this square root of function that is negative 9x plus 3 greater than or equal to 0. That's how you set up your domain. We know this is a linear inequality. So remember the rule for linear inequality, that's mommy, daddy, nanny. Which means you multiply divided by negative number. You got to switch the symbol. Therefore, first of all, you need to isolating variable on one side, I minus 3 both sides, or you cross the river, make this positive 3 into negative 3. So you got the negative 9x greater than or equal to negative 3. The next step, you got to divide it by negative 9, both sides. You got to switch the symbol because you divided by negative 9. Then we got x less than or equal to negative will be positive reduced. That's 1 over 3. Therefore, domain for number 9, that is x less than or equal to 1 over 3. Now let's go to number 10. For number 10, we know this is a rational square root of function. Make sure the radicand greater than or equal to 0. Therefore, you have to set up domain. It's this one. That is radicand x squared minus 3x minus 18 greater than 0. You got the greater than 0 format. Then your second step, you got to find the roots for this quadratic function. We set up equal to 0 now. We solve this quadratic function by factoring. That's a ninja x. You got negative 18, 1, 1, and negative 3. Negative 18, 1, negative 18, 2, negative 9, 3, negative 6. So that's the answer. We got 3, negative 6. So x plus 3, x minus 6 equal to 0. Therefore, your x1 equals to negative 3 and x2 equal to 6. Third step, you need to draw number line. We got negative 3 and a 6. Choose easy number. Let me choose 0. This 0, you need to plug in to the expressions shows greater than 0. Therefore, we got 0 squared minus 3 times 0 minus 18. That's less than 0. So we got negative 0. Since this is a quadratic function, you have two rules. Neighbor interval must be opposite to each other. So this is positive, this is positive. No equal sign, this is an open circle. We're looking for greater than 0. That means the positive interval will be the solution. We put this part is a negative, this is a positive, which means this is our solution. So we can write down solution now. Negative infinity to negative 3 and 6 to positive infinity. This will be the domain to number 10. Let's go to number 11. We know this is still rational square root of function. Remember the radicand greater than 0. We got to set up the domain like this. 2x squared minus x minus 3 greater than 0. Second step, we set up this quadratic function equal to 0 to finding the roots. Still, we got to do ninja x, -6, -1 over 2 over 2. -6, 1, -6, 2, -3. 2, -3. Remember, reduce, that is 1 over 1. Then we put the x here, x here. We factor got the x plus 1 and a 2x minus 3 equal to 0. Therefore, your x1 equals to -1 and x2 equals 3 over 2. Then we go to number line. We got -1 and a 3 over 2. Still, I'm looking for easy number. Let's get the 0. 0 is between -1 and a 3 over 2. You can get any number if you want. If you say, oh, I want to get the 2 for this side. I want to use 2. 2 is my lucky number. You can do that. Let's do plug in 2 this time. So we plug into this quadratic function. Let's plug in 2. We got 2 times 2 squared minus 2 minus 3. You got 8 minus 5 equals to 3. That's greater than 0. So this time you can see this interval is positive. For quadratic function, the neighbor interval is opposite to each other if you have 2 roots. So here's negative. This is a positive. We're looking for greater than 0, which means positive interval will be the solution. So we put the positive infinity and negative infinity here. No equal sign. This is an open circle. Therefore, solution to this interval that is from negative infinity to -1 and 3 over 2 to positive infinity. This will be the domain to number 11. One more practice for finding domain. For h of x equals 7 minus 2 times square root -4x squared plus 3x. We know this is a square root of function. Radicands we set up greater than or equal to 0. Therefore, this is our radicands. For domain, we set up -4x squared plus 3x greater than or equal to 0. Second step, we need to figure out the roots for this quadratic function we set up equal to 0. Then we factor. We got the common factor is x, -4x plus 3 equal to 0. Then your x1 equal to 0, x2 equals 3 over 4. Then third step, we need to get a number line 0 and 3 over 4. Therefore, we need to get a special number. We got 1. We need to plug in 1 into these expressions here. We got -4 times 1 squared plus 3 times 1. That is negative 0, which means the interval including 1 is negative. So neighbor interval will be positive, here is negative. Since I'm looking for greater than or equal to 0, this is a closed circle. And positive interval will be the solution. That means this interval. We can write down solution like this. From 0 to 3/4. That will be the domain to this square root function.